Okay. So students, today we are going to start a very important topic in matrices, because this is the most important topic from which the questions are coming in JEE also and in CBSE also, like board exam, your 12th board exam. Okay. So what happens is, this topic is adjoint and inverse of a matrix. Okay. So in this, we will be covering how to find the adjoint of a matrix, what are the properties of adjoint of matrices, how to find inverse of a matrix, and meanwhile we'll just see how to find the determinant also, because determinant is related to that only. Okay. Yes. So we'll start. So first of all, we'll have a quick recall, like what we have discussed in the previous sessions. We have discussed types of matrices, we have discussed operations on matrices, we have discussed transpose matrix, symmetric matrix, skew symmetric matrix, scalar multiplication and multiplication of two matrices also. So these are all the things that we have discussed. I'm sure there is no problem in any of the mentioned topics. Yes or no? Okay. So we can start today's session by today's topic, that is matrix inversion method. Okay, what is this matrix inversion method? This method is used to find the inverse of a matrix. So this is just a name for that, like how do we find the inverse of a matrix. Okay, suppose we have a matrix like this. If A is a non-singular matrix, then the unique solution of Ax is equals to B is x is equals to A inverse B. For example, see, if I have any matrix, for example, see A matrix is there, okay, and if this matrix follows this system that Ax is equals to B, so x can be easily find out using A inverse into B. So this is known as matrix inversion. So we will discuss this thing in detail also. Okay, just wait for a moment. Okay, fine. Okay, so what do we have? We have three methods to we have two methods to find the inverse of a matrix. Okay, so the first method is elementary transformations, and the second method is adjoint method. So we have to like look at both the methods very carefully, because in this method, elementary transformation, there are very techniques that are used in the questions which are directly from JEE Mains. Okay, and this method is something which is used to that requires a proper formula, and you have to apply the formula in order to find the matrix. So this one is kind of formula based. Okay, and this one is technique based. Yes. So with the help of formula, we can find any inverse for any matrix. Okay. But what is this elementary transformation? So first, let's discuss elementary transformation in detail. Okay. So what does this elementary transformation says? Like if you are having a matrix, for example, let me just consider a matrix. A is equals to like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So elementary transformations are the operations which we can perform, and we can change our matrix according to those operations. Okay. For example, this I am having as R1, this I am having as R2, and this I am having as R3. So there are certain operations which we please note that these operations do not imply for a single element. Okay, these operations always imply to the entire row or to the entire column. So likewise, we have C1 over here, C2 over here, and C3 over here. Okay, so we have R1, R2, R3 also, and C1, C2, C3 also. If any operation I am applying, so that will be not be implemented to a single element. It will always be implemented to the whole column or whole row. Okay, so what are these operations? Let's discuss in detail. So these operations are known as elementary transformation. Why the word transformation is being used? Because it can gradually transform the matrix. The entire matrix can be converted into a new different matrix. Okay. Okay. So what are these operations? See, interchange rows. We can interchange rows and columns also. Like a row can be interchanged with a row only, and column can be interchanged with column only. For example, I can use C1 interchange by C3. So now this matrix, after performing this operation, this matrix will be like this. Like this is the C1 and this is the C3. So what I'll do is I'll just bring C1, C3 to the C1. That is 369 will be here. 258 will be written as it is, and 147 will be written as like this. Okay, but please keep that thing in mind. If ever you are interchanging, then a minus sign is taken out as common. If you are interchanging any row or any column, so I have to take while doing that interchange operation, I have to take a minus sign common. That means this will be minus. Now if I again change both the rows C1 and C3, again interchange both the columns, so what I'll do, I'll put again one minus. So that minus and minus will cancel each other. Okay. So yes, this is the point. This is the point over there. Okay. So if you are interchanging any two rows or any two columns in a matrix, then what you have to do is you can simply write the new row in the place of other row, but you have to take a minus sign common also. Fine. Next operation is multiplying of rows and columns. See, we can't multiply two rows. Okay, we can't multiply two rows and we can't multiply two columns. This is very important thing to know. Like what you can do with a matrix. It is very important to learn two things: what you can do with a matrix as well as what you cannot do with a matrix. Okay, so I'm telling you, like multiplication is like this. We can multiply a scalar, any number with a matrix. Okay, but I can't multiply two rows in a matrix. For example, I am having this R1 and R2. I'll just apply R1 into R2. No, this is not possible. Yes, however, we can add rows and columns. Okay, we can add rows and columns in a matrix, but we can't multiply rows and columns with each other in a matrix. So this point has to be noted. Third one is, as I told you that we can add, we can't multiply. But if I talk about addition, multiplication, so we can multiply our entire row with any number. For example, I can do this. R3 is 3 times R4, R3. So this I can do. Why? Because I am multiplying a number to the entire row. So that is acceptable, that I can do. But I can't be like this, R3 will be R1 times R3. No, this is not possible. Okay. And what does this syntax means? See, we have like representing it with the arrow sign. That means after performing this operation, the matrix will be like this. So R3, that means to which row or to which column you are applying that operation. Okay. And this is something that what is the operation that you are applying. Okay. So is this thing clear to you, everyone? Fine. Because we will see so many questions based on this only. And once I'll doing the solution now, so you'll be like asking, sir, how is this possible? This is possible because I'm telling you right now in this slide. Okay. Yes. And it will be more clear on seeing number of questions. Okay. What are column operations? Interchange column, multiply row, add s times 1. See, so same things. Same thing that I've told you. Yeah, one more operation is there. We can also do one thing. Like we can multiply any row with a scalar and then add another row with it. We can do this. But that is a dynamic operation. Now, what do you mean by dynamic operation? That means this thing is directly like you are writing the operation. Okay. And directly you are changing the matrix. You don't have to perform it in two steps. Like first you are multiplying s by r1 and then you are adding r1. No, this is not the way. You have to apply the entire operation in a one go. I hope this point is clear. Okay, fine. Adjoint of a 2x2 matrix. Okay, guys. So I'll be giving you the trick to find the adjoint, but not in this 2x2. I'll give that trick in 3x3 matrix. Okay. And mark my words, you can easily find the inverse or adjoint of any matrix in less than a minute. Okay, with the help of that trick. Fine. So how do we find adjoint? So these are some simple steps. The first step is find minor matrix. Okay. In order to find any adjoint, these are the steps that you have to follow. So the first step is find minor matrix. Now what is this minor matrix? So minor matrix is a matrix of minors. And what is a minor? Minor is something which is of every element. It is not for the matrix, it is for the each and every element. Okay, so I'll tell you what is the, how do we find minor. Suppose I have a matrix like this. 1, 0, 2, 4. Okay. Now I have A11 with me, I have A12 with me, I have A21 with me, and I have A22 with me. Correct? Okay. Now I have to find the minor matrix. So minor is for every element. Like I'll be finding the minor matrix, so I'll denote that matrix with M. And I'll write simply M11, M12, M21, M22. So this means, like M11 means minor of A11. So whatever the element that is at A11 position, we have to find the minor for that. Now how do we find that? See, just cancel the entire row and entire column of the element, like for which you are finding, you are about to find the minor. That particular element, you have to cancel the row in which that element belongs and the entire column. Like I have to find the minor for 1, this one, right? So I will cancel the row in which 1 is occurring, like this row R1, 1 is present in R1, so I have to cancel R1, and the column of 1 is 1, column 1, so I have to cancel this also. Now what is the thing that is left? 4, so it is 4. M11 is 4. Clear? My god, now the matrix is not visible. Once again I'll write that. Yes. Now I have to find the minor for this M12. I have to find. So I'll simply go to M12, just cancel the entire row and just cancel the entire column. What is the element that is left? 2. So yes, M12 is 2. Then again I can find M21. So I'll go to M21, that is 2. I'll cancel the entire row. I'll cancel the entire column. What is the element that is remaining? 0. So yes, it is 0. And now M22. So I have to cancel the entire row, that is this row, and the entire column, that is this column. So 1 is left, that is 1. Is that okay, everyone? Everyone present over here is able to find the minor matrix. Now what is the minor matrix? M is simply just put all the minors in place of their positions. So it is 4, M12 is 2, M21 is 0, and M22 is 1, like this. So this is the first step. Like if you are supposed to find the adjoint of a matrix, then the first step is you have to find the minor, or sorry, minor matrix. So you can find out the minor matrix in this way. I am sure this is clear. Okay. Next step, second, find cofactor matrix. Find cofactor matrix. So that is pretty much clear that cofactor matrix will be the matrix of cofactors. Yes. So we have notation like Cij. Cij is supposed to be cofactor of an element, because Ij defines what? Ij defines an element. Okay. So we have Cij. Okay. Cij is cofactor of an element. So Cij can be find out using this formula, raised to the power I plus j times Mij. Okay. So this formula might be very it seemed to be very tricky. Okay, but it is not. Believe me. How I can say that? See, this is the formula, but I'll give you a trick also. Like if I have a 3 cross 3 matrix, then these are the signs. Okay, so these are the signs for the positions. Like if any element is there at A11, so its sign will be plus. Now how do we know that it is plus? Using this formula. Okay, so it will be minus 1 raised to the power, because the element is A11, that means 1 plus 1, that means minus 1 raised to the power 2. That will be 1. And 1 is what? Actually it is minus raised to the power even or odd. So every time minus raised to the power even, it will be a plus sign, and every time minus is for odd, it will be a negative sign. So that is why we have a negative sign over here, over here, over here, over here also. Okay. So you can directly do one thing. In order to find cofactor matrix, what you can do, you just find the minor matrix, and once you have the minor matrix you have written, just put these signs and fit it in the minor. So that will be your cofactor matrix. We'll be doing a question though, so that's not an issue. Okay. And third step is, now take the transpose of cofactor matrix. So now take the transpose of a cofactor matrix. Okay. So these are the three simple steps in order to find the adjoint of any matrix, whether it is 2 cross 2, whether it is 3 cross 3. Yes, this is the method, so that you have to follow. But I'll also give you a trick, not for 2 cross 2, because 2 cross 2 is very easy. In order to find the adjoint of a 2 cross 2 matrix, it would hardly take less than a minute, and you can find that. Okay. So let's solve a question on that. Okay. So suppose we have this matrix. Okay, A is equals to A, D, B, C. So how I am supposed to find the adjoint of this matrix? See, the steps are very clear. I'll first find minor matrix. So I'll execute step 1, that is M. So M will be, now the minor for A is what? I'll slash the row in which A is falling and slash the column. So the element which is left is C. Okay, you can also do this with your finger. Like you can simply put a finger, okay, on the entire row and on the entire column. So the thing that which is left will be your minor. Similarly, like if I put a finger on D, so D and D. So this row and this column will be slashed out. So it will be B only. Now what is the minor of B? It is C. Wait, sorry, it is B. I was not able to see it. Yes, C, and this one is B, and this one is A. Okay, so this is the minor matrix. Now I have to find cofactor matrix. So what is the sign for this? See, this is A11, so that means this is having a plus sign, and this is A12, so it is having a minus sign. This is A21, it is again having a minus sign. It is A22, that means it has plus sign. So I'll write C only, but I'll write minus B over here, and I'll write minus D over here, and I'll write A over here. Is this step clear to you? Like, what do we do for cofactor? Just place the minor matrix and just superimpose the signs of the positions into that matrix. Now take the transpose, that means the CT. So CT will be, this is actually your third step. CT will be C and minus D, and minus B and A. So this is the answer. Okay, so this is the adjoint. I can say this is the adjoint of A. Now how do I write adjoint of A? Like, there must be some sort of notation, na? So that is ADJ of A. So it is written as ADJ of A. ADJ of A means adjoint of A. Okay. Everybody, is this clear to you? Kritika, why your camera is off? Trivikram, why your camera is turned off? Sutika, Kyle. You guys have to turn on your cameras, no? There is one thing that I would like to ask before we proceed in this session. Like, I have been observing you guys from past, I guess, 3 to 4 lectures, right? or maybe more. But there is this thing with you guys that you guys don't speak. Why? Is there any problem? Like why you guys turn off your mics? Can you imagine like how how much it is boring for me also to deliver this lecture? I am the one who has a duty to speak for 2 hours, and you on the other side, you are the ones who are just sitting, giving some sort of facial expressions. So guys, try to interact. Okay, try to speak. Getting my point or not? If anybody would have actually got my point, na, then he or she must have spoken in the meantime. Okay. See, so this is the adjoint that we have. Okay. Okay. So time for a trick. Time for a trick. Okay, I won't tell you the trick. I changed my mind. First, turn on your cameras. Sorry, mics. Trivikram, you turn on your mic. Okay. And Hari Mahesh, you turn on your mic. Okay. We have to give you the feedback of the trick. Okay. I am going to show you the trick. I'll first show you the actual method also, and then I'll try to, and then I'll obviously disclose the trick. You have to give me the feedback, like whether it is effective or not. Okay. Adjoint of a 3 cross 3 matrix. Trivigram, just name any random number.
1 5
Speak loudly.
1 5
1 5
7
7
3 2
3 2
5
5 5
9 2 1.
9 2 1 9 2 1. Okay. See, first we'll talk about the genuine method to find the adjoint that I have discussed also, but I am not going to do that. Okay. So what is this? What is that? First we have to find the minor matrix. Okay, fine. I was discussing the minor matrix for 2 cross 2 matrix. Now this is 3 cross 3 matrix. So I have to stop for a moment. Okay. So before that trick, I'll be telling you how to find the minor matrix of a 3 cross 3 matrix. Okay. So yeah. See, how do we find the minor of 3 cross 3 matrix? See, suppose I have to find M11. Okay, so I'll check like M11 is falling in which row and which column. So M11 is clearly falling in first row and first column. Okay, so what I will do is I will as I did the same thing in 2 cross 2 matrix, I'll cancel this entire row and cancel this entire column. Okay, fine. But right now there is no one element left. There are 4 elements. Like this is something which I have found after cancelling the rows and columns. So what is this? So there is one extra step in 3 cross 3 matrix to find the minor. Now you have to cross multiply the elements and take the difference. That means you have to multiply this by this and this by this, and you have to take the difference. So 2 into 1 minus 5 into 2. That is 2 minus 10, that is minus 8. This is clear?
Yes, sir.
Okay. So this is the reason that adjoint of a 3 cross 3 matrix takes time. Because minor matrix, it will take so much time to find the minor matrix only. See, we have to find minus 8 is there. Okay. Now I have come to 5. So now what I will do? I'll again
3 minus 45.
yeah, cross this line and cross this line. So 3, 5, 9 and 1. These are the 4 elements. So what is the like answer? So it is 3 into 1. See na, 3, 9, 5, 1 is remaining na. So 3 into 1 minus 9 into 5. So it will be 45 here and 3 here. 3 minus 45 is what? Minus 42. So similarly, we'll find this, 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 and we'll find this. Okay. So
Okay,
if
sir.
I say that 10 to 15 seconds is required to find one minor, so 15 into 9, okay, 135 seconds, just for minor only. Fine. So this is the first step. Everybody just let me know, like you are able to find the minor matrix for a 3 cross 3 matrix, no?
Yes, sir.
Or should I
Yes, sir.
do that?
No, it's fine, sir.
No, it's fine. Okay, fine, fine. So we can now come to the trick part, okay? So what is this? Like we have completed the minor matrix, then we will find eventually cofactor, and then I'll take the transpose, and this will be the inverse, right? We don't
Yes.
have to do that in JEE. In CBSE, trick is not allowed. Why not allowed? Because obviously, because there is a certain method, there is certain technique which is to be there in order to find the adjoint. So they will not allow you if you just apply the trick over there. So they will simply cancel. So no marks would be given to you if you apply trick. Okay, because that is CBSE, that is board. But you have to save your time, na? That is why the trick is there. Okay, see what is the trick. Trivikram, can you please repeat this matrix one more time for me?
This one, this, sir.
Yeah, same, 157.
Sir, first row, first column, one element should be multiplied with second row, third column, and
Huh? Sorry?
we should not take that first row and first column, sir. We should multiply with second,
I'm
the
not.
2, 1, and 1.
Please, I beg your pardon. Just repeat it. Whatever you have said.
Sir, we should not take first row and first column. We should multiply that 2 and 1 minus 2 into 5. For
2 in.
5, we should.
No, in which step you are asking?
Man,
Like in which step you are asking? I'm asking you the way.
normal, no, sir. Normal.
No, while finding minor or while finding cofactor?
Minus, sir.
Minor. So what is the problem?
It takes time. That's it, no, sir.
Yeah, it will take time. No? That is why the trick is here. It will take time because you have to repeat that process 9 times. Because 9 minors are there that you have to find.
Yes, sir.
It will take time, yes. That is why I have brought you this trick now. I was asking, please repeat this matrix one more time because I am writing on a fresh page.
Okay, sir. Okay, sir.
Okay. I don't know what suddenly what. Yeah.
I thought you said it explain, sir.
Okay. Tell me what is the matrix.
1,
1,
5, 7,
5, 7,
3, 2, 5,
3, 2,
5,
5,
9, 2, 1.
9, 2, 1. Okay. So this is the matrix.
Yes,
Suppose we have. Okay.
Yes, sir.
And we have to find this adjoint of A. Okay. 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 So what I have to do, what I'll be doing is, see, just write this matrix 1, 5, 7, 3, 2, 5, 9, 2, 1. Tell me, are you able to write this? Of course, because this is something that is given in the question only. Okay. Now repeat C1 and C2. So you will write 1, 3, 9, 5, 2, 2. Clear? Clear? You have to repeat C1 and C2. I am repeating C1 and C2. Now I will repeat R1 also. So R1 is 1, 5, 7, 1, 5. This is R1. This thing is clear to you?
Yes, sir.
Okay. Now what you have to do is you just have to eliminate this first line and eliminate this first column. Like first row and first column you have to eliminate simply. Okay?
Yes, sir.
Okay. Now what you have to do is, see, just multiply this and this and take the difference. So this is 1 into 2, that is 2, minus 2 into 5, that is 10. So 2 minus 10 is what? Minus 8. So I'll write minus 8 over here. Okay. And now I'll perform this multiplication, 9 into 5 minus 1 into 3. So 9 into 5 is 45, minus 1 into 3 is 3.
40.
So 45 minus 3 is 42. Correct?
Yes, sir.
So instead of writing this 42 over here, I'll write over here. Okay. And 3 into 2 minus 9 into 2. 3 into 2 is 6, 9 into 2 is 18. 6 minus 18 is minus 12. I'll write over here. Now I'll do this. 7 into 2
9, sir. 14
minus 5 into 1.
9.
7 into 2 is 14 first of all, and 5 is 14 minus 5 is 9. So I'll write over here, and this 1 minus 63, that is minus 62, and this 9 5 45 minus 2, this is 43. Okay,
Yes,
clear?
sir.
Yes, sir.
Okay, I think in the hurry I just skipped R2 also, because I have to write R2 also, no? So 3 2 5 3 2 again I have to write 3 2 5 3 2. So this will again eliminate. Yes. Now the last operation is 5 into 5 25 minus 7 2 is 14. What is 25 minus 14?
11.
11 will be written over here. 7 3 is 21 minus 5. What is 21 minus 5? 15. And what is 2 minus 15? Minus 13. See, this is directly your adjoint. Okay. So we can also see the time complexity, like how much time is saved when you apply this trick.
Yes,
See,
C2.
see, in writing C1 and C2 two times, it will hardly take you 2 seconds, right? And in writing R1 and R2, it will hardly take you 2 seconds. And in crossing these first row and first column, so the total time is 5 seconds for doing that. Okay? And one such operation, like 2 into 1 minus 5 into 2, that is minus 8. So one such operation is of like how many seconds? Let us suppose 3 seconds, right? So 3 into 9 is what? 27 seconds. So 25 plus 27 plus 5 is 32. And I'll give you 8 seconds more, 40 seconds. So you can find the adjoint of a matrix in less than or in 40 seconds. Okay? What was the trick?
it's good, sir.
Okay.
C2.
So everyone over here, like who has that idea? Like, you know that trick before also?
No, sir.
No, sir, they didn't teach us.
Okay.
It's not allowed, no, sir.
No, don't just justify them that it is not allowed. Don't defend them. There's one possibility also that they might be not knowing also, right?
Yes,
Because
sir.
there are in maths there are so many hidden secrets. You know, like math is a subject. It is like a deep sea. So the one who dives deeper has able to extract all the secrets. You know, this is the logic. So that depends, like in how much depth you are going. Usually people don't dive that much. That's not an issue. I'll be taking many lectures for 12th, okay, and this is something that is like not up to the mark also, because that is a very simple topic, matrices and determinant, right? So we don't have any more tricks, we don't have any good questions in JEE. Once I'll start calculus now, then you will like you will be able to see like how much secrets I am holding with me. Okay,
Yes, sir.
fine. Just wait for limits. Okay. So we have covered adjoint of a 3 cross 3 matrix. Okay. have covered adjoint of a sequential matrix, correct? So guys, I am giving you one matrix and you have to find the adjoint. Let me know, okay? I'll give you a proper 1 minute. Find adjoint of A. I'll be back in a moment. Huh? Meanwhile, you guys have to find this. Yes, students. So adjoint is like Sudarshan is saying, my friend told me this, sir. Okay, fine. First row is 5, 7, 5, minus 7, 8. Second row is minus 9, 1, 3. Third row is 2, 3, minus 20. Everybody please check whether the answer is correct or not. Okay, I'll be doing this with you, okay? So 1, 4, 1, 6, 4, 3, 1, 1, 2. Okay. So I'll write 1, 6, 1 and 4, 4, 1. And I'll write 1, 4, 1, 1, 4 and 6, 4, 3, 6, 4. Now I'll cancel this. So 4 2 is 8. 8 minus 3 is 5. So I'll write over here 3 minus 12 minus 9. 6 minus 4, 2. 1 minus 8 minus 7. 2 minus 1, 1. 4 minus 1, 3. 12 minus 4, 8. 6 minus 3 is 3. And 4 minus 24 is minus 20. This is the answer. This is the answer? Yes, okay. Fine. So just note this. Okay, so moving on. See this in the slide I have put it that technique, like you have to find minor first, then cofactor, then transpose, and this is adjoint. Okay, okay, this is something which is very, very, very important. Properties of adjoint of matrix. Properties of adjoint of matrix. Okay, so you have to note each and every property, because you will not know, you will never know like what is the question, like how is this framed from that property. Okay, so very important properties are there. If you multiply A into adjoint A, okay, that is equals to adjoint A into A, and that is also equals to AI. Okay, fine. Second one, determinant of, this is very important property, because we can see so many questions are based on this property. So determinant of adjoint A is, see this sign. Okay, I'll tell you guys, like if somebody is having here which is having no idea of determinant. See, this is the sign that we use for matrix. Okay, and this is the sign that we use for determinant. Okay, what is the difference between a matrix and a determinant? What do you mean by determinant? See, matrix, I know, I told you that we know that this is an array, okay, in which elements are placed in rows and columns. But determinant is that value of that matrix. If I ask you like what is determinant, then you are finding the value for a particular matrix. So that is determinant. Okay, value of matrix. Okay, so that is denoted using this mod sign. So adjoint A mod is equals to mod A n minus 1. Okay, so determinant of adjoint is equal to determinant of A power n minus 1, where A is invertible n cross n square matrix. Now there is this third property. Please note down, adjoint of A is equals to mod A raised to the power n minus 2. We have some JEE based questions from directly from properties. Okay, please note each and every property very carefully. Fourth one is adjoint of AB is adjoint of B into adjoint. This is also very important. Like if you are having two matrices, so first multiply those two matrices AB and then take the adjoint, and then you have to find individual adjoints of two matrices. So that is never adjoint A into adjoint B. It is adjoint B into adjoint A. The order of AB is reversed. Okay. And this property adjoint A whole transpose is adjoint A transpose. Like you can find the transpose, then you can find the adjoint, or you can find the adjoint and then you can find the transpose. So both are same. And this is also very important. If any number is multiplied in adjoint, right? So it can be taken out as common, but its power will be n minus 1. And n is the order of square matrix. For example, 3 cross 3, n is 3. 4 cross 4, n is 4. Okay, so these are some important properties, okay, that you have to note it down, because we will be solving some questions directly based on this. Have you guys noted each and every property? Fine, I'll wait. Sorry, actually there was some important call. Okay. So find the cofactor matrix. This is very simple question. You can easily find the cofactor matrix, right? So I'm not going to solve any question. You have to find. Let me know the answer quickly. You have to find the cofactor matrix for this one. Those who have done, just give me a thumbs up. Kritika is done. So anybody else? Done. Okay. See what is the point over here. I've told you the trick now. Like you have to find the adjoint using that trick only. Okay. If you are like attempting the question for JEE. So in that step, what I am doing is in the last step of finding the adjoint, I am like writing this 102 minus 213 0 3 minus 5, and then I'll write C1 and C2. So it will be 1 minus 2 0 and 0 1 3, and then it will be R1 and R2. So it will be 1 0 2 1 0 and minus 2 1 3 minus 2 1, and I'll just eliminate these two, first one first column. Now if I'm doing this now, so this is already a cofactor. So 5 into 1 is 5, minus 3 into 3 is 9. So 5 minus 9 is what? No, this is minus 5, no? Yes. So minus 5 minus 9. It is minus 14. So I'll write minus 14 here. Now if I perform this operation, so then the answer will be 0 minus 5 into minus, that is 10, plus 10. So I will write here only, because I was writing here in case of adjoint, but in case of transpose I will write here only, because in the adjoint the last step is to take the transpose of that matrix, right? So this was the thing. So I'm sure like everybody has got this, right? Okay. X is equals to 2 minus 2 4 and 3, and then find A inverse by the adjoint method. Okay, so there is this question from inverse. like we haven't discussed inverse yet. Okay, so we'll first discuss inverse of a matrix and then we will come to this question. Find the adjoint of matrix A. Quickly solve this one also. Find the adjoint of matrix A. Come on, everybody. Done? Okay. So everybody, has everybody completed this question? Fine. Kritika, you? Sorry. You are doing or you have completed? Okay. Fine. Completed. Fine. Fine. Okay. So now this is the question which is like based on property. You have to verify A into adjoint A and adjoint A into A is mod AI or not. So I think the process is clear to you. You have to first find adjoint A and then multiply it by A. So there is two steps involved in this question. First you have to find the adjoint and then you have to find the multiplication of that adjoint with the matrix itself, A. Please find this and check whether like both are equal or not. Okay, I think the process is clear to you, everyone. You have to find the adjoint of this A matrix first, and after finding the adjoint, you have to multiply it with the A matrix. Then your LHS will be formed. And similarly, you have to repeat this process, and then RHS will be formed, and you have to check whether LHS is equal to RHS or not. Okay. Just go through this one also. Completed everybody? Still doing? Okay, fine. Completed now? Okay, students, you can attempt it later also. Okay, fine. So now this is the question that we are having, that is from JEE Mains. Okay, see what is the question is saying. Let a is equals to this greatest integer of x plus 1 and greatest integer of x plus 2, greatest integer. See what is this symbol? As I've told you also that this is a GIF function. Tell me how many of you remember GIF function? Trivikram, you remember GIF? What was there in that greatest integer function? Yazira, you remember? Yes. See, I'll tell you like what is greatest integer function. Suppose if you give any integer as an input, for example 2.5 you are giving. So the answer will be 2. Why 2? Because you have to check 2.5 lies between which two integers. So it lies between 2 and 3. So the smallest of these two integers is known as is your answer. Okay. So all of these x are enclosed in a greatest integer function. See, it denotes the greatest integer less than or equal to t if determinant of a is 192. Then the set of values of x is the interval. Okay, fine. So you have to find the interval of x. Okay. How we are going to solve this question? Using elementary row transformation. Okay. I'll be telling you how we have to solve this question. Wait, huh? Yes. So this question will be solved using elementary row transformation. We have discussed this in class. I've told you how, like, what do we do in elementary row transformation? Okay. See. So this is greatest integer of x plus 1. Okay. And this is greatest integer of x plus 2. And this is greatest integer of x plus 3. Now we can say that this x and this x is there. So we can do one thing. See, all our motive is, the whole motive to solve a determinant or to solve a matrix is just create maximum number of zeros. And it is very good if you are able to create maximum number of zeros in a single row or in a single column. Okay. So I can do this na R2 minus R3. So by doing that, this will be eventually become a 0. And see, there is this x plus 2 and x plus 2. So I can also do that R1 may R1 inside R1 I can do that R1 minus R3. Yes or no? Or I can do that, see x plus 3 and x plus 3 is also there. So I can also do that R1 in R1 I can do that R1 minus R2. So I'll be applying any two operations. Okay, so I'm applying right now. Okay, so we can create a 0 over here and we can create a 0 over here. Okay. So applying this operation, finally, just wait for a second. Okay, I'll write it in a proper manner. Yes. So I'll apply In R1, I am doing R1 minus R3, sorry R2, and in R2, I am doing R2 minus R3. So what will happen in this case? Now whole R1 will be changed and whole R2 will be changed. Now how R1 is going to change? It is going to be R1 minus R2. So first of all, it is root x plus 1. Oh, sorry, not root. GIF of x plus 1. So GIF of x plus 1 minus GI of x I have to write. Okay, like this. And this is GIF of x plus 2 minus GIF of x plus 3. And this is 0. Okay. And this is 0 because GIF of x minus GIF of x will be 0. And this will be x plus 3 minus x plus 2. And this will be x plus 3 minus x plus 4. Okay. And the third row will be written as same. GIF of x plus 2 and GIF of x plus 4. Okay. Now what is this? Now x plus 1 minus x is what? It is 1 only. And GIF of 1 is what? It is 1 only. Right? And now what is this? X plus 2 minus x minus 3. So it is 2 minus 3, that is minus 1. Okay. And GIF of minus 1 is minus 1 only. So likewise you have to solve. Okay. So just wait for a second. I'll be bringing this question to the whiteboard. Because there is no space left. This is the question, right? Okay. So once I apply this R1 minus R2 inside R1, and in R2 I have applied R2 minus R3. So x plus 1 minus x is 1. X plus 2 minus x plus 3 is x plus 2 minus x minus 3 will be 2 minus 3 minus 1. And GIF minus 1 will be minus 1. And this is 0. And this is 0 again. X plus 3 minus x minus 2. 1 x plus 3 minus x minus 4. So it will be again minus 1, that is minus 1. And this will be simply root x, sorry, GIF of x plus 2 and x plus 4. Fine. Now guys, pay attention because I am about to tell you how to expand a determinant. How to expand a determinant. Okay. Because the question is asking me the value of determinant. So this is a determinant. Now how do we expand determinant? So a determinant is always expanded using any row or any column. Okay, so you can expand a determinant along any row or along any column, but it is very wise and it is very like sensible decision to pick that row or that column in which there is a maximum number of 0. Okay, so right now in R1 we are having 1 0, in R2 we are having 1 0, but in R3 we are having nothing. Similarly in C1 we are having 1 0, in C2 we are having nothing, in C3 we are having 1 0. So I can expand my determinant along either C1 or C3 or R1 or R2 because all the 4 mentioned things contain zeros. Fine. And you can also expand it using R3 also. The answer will be same. Like you can expand the determinant from any side, any row, any column. The answer will be same from each and every row and each and every column. So I will just expand along R1. Okay. So why this fact is used, like we have to pick that row in which maximum number of zeros are there, because eventually it will save your time because calculation will be less in case of zeros. So now how do we solve it? First we have to write the first element. So first element I will write. Okay. And then I'll do that same thing, the thing that I was doing in the minor. Like I will slash this line and slash this line. Okay. Now I'll take the cross multiplication. So cross multiplication is x plus 4 minus x plus 2 plus x plus 2 it will be. Yes? Yes or no? Because this x plus 4 is multiplied by 1 and minus this 1 is multiplied by x plus 2. Okay? Similarly, minus 1 will be written. Minus 1 is the second element because I am expanding along R1. So I'll write minus 1. But there is one sign also of this position. So we have to write the element also as well as the sign also. So we have to write the element also as well as the sign also. So I was writing 1 over here because 1 is the element. But plus sign is there because plus sign is for this position. And similarly, if I talk about this position, then minus 1 is the the element is having minus sign. But there is one sign of its position also, and that position has minus sign. So I'll again write one minus, so that will become plus. Got it, everyone? So I'll write plus 1. Now plus 1, again I'll like this and this. Eliminate this one, this column. So there will be 0 into x plus 4 minus x. Right? So that is 0 only. And minus 1 into x, that is x only. Okay. So what we have got? We have got greatest integer of x plus 4 plus greatest integer of x plus 2 plus greatest integer of x. Okay. Now greatest integer function has a property that suppose a plus x is there now. So we can write it as greatest integer of a plus greatest integer of x. This is the property of GIF function. So it will be greatest integer of x plus greatest integer of 4. And it will be greatest integer of x plus greatest integer of 2. And it is again greatest integer of x. Now all this thing it has been given to equal to something. Just wait, huh? Yes, it is equal to 192. The thing is equals to 192. So I'll put that equals to 192. Okay. Now what is greatest integer of 4? It is 4 only and it is 2 only. And 3 times greatest integer x plus 6 is equals to 192. 3 times greatest integer of x is equals to 192 minus 6, that is 188. Okay. So greatest integer of x is what? It is 188 by 3. Yes. So 188 by 3 is what? Like 3 6 are 18 and 62 point something we have got. Okay, 62 point something we have got. That means the range is, we'll check for options. Yeah, we have 62 and 63, this range, right? So B is the correct option. This question is clear to you, everybody? Sure? You want to copy this? You want to copy this? Okay, so wait, I'll open that page for you. This is visible or not? Okay, fine. So guys, there's a short break for all of you. Okay, so I'll be joining back with you guys in 10 minutes. Okay. Okay. Yes, everybody. Let's resume this class. Okay, so we have another question. Okay, anybody want to give it a try, or should I solve it? And guys, please just turn on your cameras. I can only see 2 of you are turning on your cameras. Everybody just turn on. Yes. Okay. So what is the concept behind this question is, it is given that somewhere it is a matrix, A matrix is there. I don't know what matrix is that. Okay. But adjoint of A is given to me. Like I don't know the value of A, but adjoint of A is given to me. And the question is asking what is the value of determinant of A. Okay. Question is asking what is the value of determinant of A. So this thing I have to find. Okay, so what I can write is, see, adjoint of A, I have told you what is this. Like if I ask you, this property I have told you, na, adjoint of A is what? It is mod A raised to the power n minus 1. Yes or no? Determinant of adjoint A is always equals to determinant of A raised to the power n minus 1. And since this is adjoint of adjoint A, that means it will be, okay, n is what? N is 3 over here. So that means it is mod A square. Now adjoint of adjoint A will be, it will be mod A square to whole power 2. So it will be mod A raised to the power 4. Okay. So this thing I have calculated that this thing is for sure. What is this? This thing is mod A raised to the power 4. Okay. Okay. But here it is written that adjoint of A is something like that. It is a matrix, not determinant. So what we can do is I can take determinant on both sides. Okay. So now this will become mod A. Wait, I'll draw a line over here. Yes. So now this will become mod A raised to the power 4 is equals to mod of this whole 14, 28, minus 14 and minus 14, 14, 28, again 28, minus 14 and 14. Okay, now I can easily see that 14 can be taken out as common from the entire row. Each and every element in R1 is having 14 as common. So I can take 14 as common from R1. Similarly, I can take 14 as common from R2, 14 as common from R3. So 14 3 times will be taken out as common. So what will be left inside the determinant? It is 2 only, and it is, no, sorry, 14 is taken out as common. It will be 1. Yeah, it will be 1, it will be 2, it will be minus 1. And this will be minus 1, 1, 2, 2, minus 1, 1. Right? Mod A raised to the power 4 is equal to, like this. Now we will solve this determinant. Okay. So how do we solve this determinant? So we'll solve this determinant expanding along. Since we have no zeros, so we can expand from anywhere. So I am expanding along R1. Okay, and since these are very small values, so I can directly expand. I don't have to perform elementary operations over here, and I don't have to find the value to create the zero also. Okay, so that will be 1 time 1 into 1 minus 2 into 1. So 1 minus minus 2, that is 1 plus 2. Minus 2 times, this will be 1 into minus 1, that is minus 1, and minus 4. And minus 1 times minus 1 minus 2. This is minus 1 into minus 1. This is minus 5 into minus 2. And this is 3. So we have 3 plus 1, 4 minus 10, 14. So we have 14 as answer. So the value of this determinant is, this entire determinant is 14. So I can see that mod A raised to the power 4 is 14 raised to the power 4. Yes or no? So I can simply say that mod A is 14. Now this is my answer. Because the question was asking the value of determinant. No? So determinant means what? Mod A. That's it. I have the answer. everybody please note that. The entire question is visible, or should I zoom it? The entire question is visible, or should I zoom it? Visible, okay. Okay, final warning to the students. Sudarshan, Hari Mahesh and Kritika, you are going to be in this session, okay? And rest of them I am going to remove. How smart you guys are, right? Yes, I have removed one student from this session, okay? I will not tell you the name. And there is one more student that I have to remove. Fine. Now if somebody is there who is not turning on his camera or mic, no, mic is fine, but if it is not turning on his camera, I'll simply remove. I'll not, like each and every time, I'll not tell you guys, okay, to just unmute or turn on the camera. That is really very frustrating for me. Okay, fine. So have you noted this question? So only one last topic is remaining, and then we'll have to solve some questions. What is that last topic? That last topic is inverse of a square matrix. This is very important, inverse of a square matrix. Okay. How do we find inverse of a square matrix? Inverse of a square matrix can be easily found using two methods. As I have discussed also, one is your ERT, that is elementary row transformation, and one is your formula, that is A inverse is equals to adjoint of A over determinant A. Please make sure we are not going to learn why, because this is reduced in CBSE. So elementary row operations are not there, but yes, this is a technique that we should know. That is why I told you. Okay. So elementary row, we are not going to find inverse using this elementary row transformations now, because that is reduced in CBSE. So now we will be doing only this thing. Okay. So please make sure there is one common point also. A inverse, you can see the formula. A inverse is adjoint of A divided by determinant of A, right? So there is no need to find adjoint first of all. So in case of finding inverse, you have to always find determinant first. Why you have to always find determinant first? Because what if determinant A comes to be 0? Now anything upon 0 is what? It is not defined. So inverse will not exist when determinant is 0. Again I am telling you, inverse will not exist if determinant A is 0. That means if determinant A not equals to 0, A inverse will exist. And if determinant A equals to 0, A inverse won't exist. So there is this common point, common sense, according to that common sense, like you have to always calculate determinant first. What if determinant is 0? Then all your time will be wasted that you consumed in finding the adjoint, right? So you have to never find this first. You have to always find this first, and just stop if determinant A is 0. Okay. So this thing is clear. I guess you guys have the knowledge how to find determinant. You guys have the knowledge how to find adjoint. So now there is one thing which is division, right? Adjoint is a matrix. Agreed? And determinant is always a value, that is it is always going to be a numerical value. So how do we divide in matrices? See, we are not dividing the two matrices, right? Like whatever.
Sir,
Sorry, yes.
this is Hari, sir. Can you just, with a simple matrix, can you just show how to find determinant again? I kind of lost you at one point.
Okay, don't worry. I'll be like telling to you. Fine. So we'll bring that question only, okay? Okay, so before we go to the question, just this is the last slide uh, of theory, like properties of invertible matrices. What is the property? See, only so many rubbish things are written over here. Okay, so I'll mark what is important. This one is important, this one is important, and this one is important. Okay, and this one is also important. Only 4 points you have to copy. So A inverse of A inverse is always A. That is true. Okay. And if you are multiplying two matrices and then taking the inverse, then you can also do that in this manner. Like you have to find individual inverses and you can multiply them. This is very important. If any number is multiplied in a matrix, then its reciprocal is jumped out 1 by k. Okay. Fine. So I have to find the inverse of this matrix. This is very simple because this is a 2 cross 2 matrix. So how I'll write first of all formula, that is A inverse is equals to adjoint of A over determinant A. Now I'll find determinant A. Okay. So determinant A is what? It is minus 1 into 1 minus 2 into 2 minus 1 minus 4 minus 5. Since determinant A is not equals to 0, that means inverse will exist. So now I'll find adjoint. The adjoint is what? Since it is a 2 cross 2 matrix, so adjoint is very easy. I have to find minor cofactor and then take the transpose. So minor will be minus 1. For 2 we are having 2. And for this 2 we are having 2 again. And for this minus 1 we are having 1. This is the minor matrix. Cofactor matrix will be just plus minus minus plus. Okay, so plus is it is minus 1 only, it is minus 2 and it is minus 2 and it is 1. Okay, and now take the transpose. So CT will be what? CT will be this. Now this is the adjoint and this you have to divide it by minus 5. So every element you have to divide it by minus 5. So the final answer will be what? A inverse will be minus 1 by 5. It will be 1 by 5. Okay, 1 by 5, 2 by 5. It will be again 2 by 5. It will be minus 1 by 5. So this is your answer. Okay. So this is your answer. In this manner you have to find inverse. Inverse is clear, formula is clear. Now Harimesh, I will tell you how to find the determinant of a 3 cross 3 matrix. Okay. Anybody wants to note this down? No. Still I am giving you a 1 minute. If anybody wants to note it down, yes, you can note. Okay. So moving on. Okay. Now we have this matrix with us. Okay. So Harimesh, I am going to tell you the determinant and rest each and everything you have to do it on your own. Fine. Okay. So determinant is C. We'll draw two lines which represent determinant. I'll write 2 0 minus 1 over here, 5 1 0 over here, and 0, 1, 3 over here. First of all, you have to select one row or one column by which you are expanding the determinant. So you have to take care of that selection. Like you always select that row or that column which contains maximum number of zeros. Okay. But since we can see that in our determinant, only one zero is there in any row. Like if you talk about R1, there is only 1 0. If you talk about R2, there is only 1 0. If you talk about R3, there is only 1 0. So we can expand by any row. So yes, I will expand by R1. So I will expanding along R1. Okay. Expanding along R1. I'll write 2 first of all. First element, which sign you have to write? Which sign means sign of what? Sign of that position, not that sign of element. So 2 is having no sign, so it is written 2 over here. Okay. But plus sign is also for that position. No? So I have to write plus 2. And then I'll simply remove this row and remove this column. And what is the 4 elements that are left? And I have to take the cross multiplication and difference. Same process that we have done in the case of minus. So 3 into 1 minus 1 into 0. So 3 into 1 minus 1 into 0. So it like this. Okay. And then we will not write 0. Why? Because we'll write 0 and then we'll do the multiplication and all. We'll do the calculation. So what is the result? The output is 0 only. So we'll not write 0. Okay. So now what we'll be writing? Now we'll write minus 1. Okay. So now minus 1, again I have to remove this line and this line. So now what is the thing that is left? 1 into 5 minus 0 into 1. So 5 minus again 0. So we have 2 into 3, that is 6, minus 1 into 5, that is 5. That is 1. Since determinant A is equals to 1, it implies that A inverse do exist. Okay. So now you have to find A inverse. How? By using this formula, A inverse is equals to ADJ, adjoint of A upon determinant A. Just find adjoint of A and divide each and every element by 1. Obviously, it will be adjoint of A only, right? Yes. Find the adjoint quickly, everyone. Hari Mahesh, this is clear to you? Okay. Yes. Completed. Okay, this question we can skip because this is a question which says that you have to find the inverse using elementary row transformation. So you can note this question and you can try it on your home also. Okay, but we will not waste our time. Just give me a thumbs up once you've noted this question. Okay. Noted, everybody. Okay, now we have this question. Anybody wants to give it a try? First, I will tell you how this question is going to be solved. Okay, and then you can attempt this one. Fine. P. Let A is equals to 1, 2, minus 1, 4. And A, this is from JEE Mains actually. Such an easy question. 1, 2, minus 1 and 4. If A inverse is equals to alpha I plus beta A, okay, and alpha beta belongs to real number, I is a 2 cross 2 identity matrix, you have to find 4 times alpha minus beta. See how we are going to do that. The questions from matrices and determinants are never going to be difficult. Okay, all you have to remember is you should be well versed with the concepts. Okay, so the questions clearly says that you have to find the A inverse. Okay, so I'll be finding A inverse first of all. So A inverse will be again adjoint of A over determinant A. Okay, so what is adjoint of A? No, what is determinant A first of all? It is 4 minus 2, that is 4 plus 2, that is 6. Okay, so it is adjoint of A over 6. Now what is adjoint of A? I'll find minor matrix quickly. So it will be 4, it will be minus 1, it will be 2, and here it will be 1. Now I'll take the cofactor. So cofactor matrix will be, it will be 4, it will be 1, it will be minus 2, and it will be 1. Now transpose will be adjoint itself. So 4, 1, minus 2, 1. Okay, and divided by 6. So A inverse is what? A inverse is 4 by 6, minus 2 by 6, 1 by 6, and 1 by 6. This is A inverse. Okay, this is what? This is A inverse. Now, what is A inverse actually? A inverse actually is alpha I plus beta A. So I know that it is 1, 1, 0, 0. So what will be alpha I? Alpha I will be alpha, 0, 0. Yes, each and every element you have to multiply it by alpha only. Similarly, A I know, that is 1, 2, minus 1, 4. So what will be beta A? I'll write somewhere here. Beta A will be just multiply each and every element with beta. So what was that matrix? 1, 2, minus 1, 4. So 1, 2, minus 1, 4. Sorry, we have to multiply it by beta also. Okay, so this is A matrix. So it implies that beta A will be beta, 2 beta, minus beta, and 4 beta. Now the question is saying that A inverse is actually what? It is alpha I plus beta I. So I have to add alpha I and beta I first. Okay, so what will be alpha I plus beta I? So I'll simply add, this was alpha 0, 0, and this is beta to beta minus beta and 4 beta. Now what is the addition? Addition is alpha plus beta and 2 beta plus 0, so it is 2 beta only. 0 minus beta, it is beta only, minus beta, sorry, and alpha plus 4 beta, This is alpha I plus beta I, and the question is saying that it is equal to A inverse. The question is saying that it is equals to A inverse, and we have A inverse with us now. What was the A inverse that we were having? We were having A inverse to be 4 by 6 minus 2 by 6. All right, 4 by 6 minus 2 by 6, 1 by 6 and 1 by 6. Now if these two matrices are equal, you can simply compare. So I got that alpha plus beta is, on comparing, wait, I'll write properly, on comparing I'll get alpha plus beta is equals to 2 by 3. 4 by 6 is 2 by 3. I'll get 2 beta is equals to minus 2 by 6. So this brings me to beta is equals to minus 1 by 6. Okay, now alpha minus 1 by 6 is 2 by 3. So alpha is what? 2 by 3 plus 1 by 6. I into 2, that is 4 by 6 plus 1 by 6, that is 5 by 6. Okay, so now what was the question asking? Question was asking 4 times alpha minus beta. So what is 4 times alpha minus beta? So it is 4 times alpha was 5 by 6 and minus beta was 1 by 6, right? 4 minus 1 by 6, that is, sorry, 5 by 6 minus of minus 1 by 6, that is plus 1 by 6. So it is 6 by 6, that is 1 only. So answer is 4. 4 into 1, that is 4. So D is the correct option. Okay. Oh God. Wait, I'll now zoom. Yes. Now everybody can note from here. This is visible? Okay.